Hello class, this is Miss Riggins coming to you with the new unit that we're starting on similarity. And before we start talking about similarity, we need to refresh what we know about ratios and proportions, and then we're going to introduce some new terminology. So it's very important that you take the notes on page 89. You can print them out or copy them down, but it's very important that you have them. We're going to be going over a lot of new vocabulary and some old vocabulary, and it's important that you have a reference. So you guys are familiar with the concept of a ratio, and ratios are used to compare two numbers A and B. So here we have A and B. And if A and B are two numbers and B is not 0, then the ratio of A to B can be written one of three ways. You can say A to B, or you can say A divided by B, or you can use the colon notation, which you guys may remember from middle school, which says, and I'll just add it on here, A to B. Okay, so those are three ways to represent a ratio, and either which way is perfectly fine. Now, for the purpose of this course, it's so much easier to deal with ratios if and only if A and B are simplified positive whole numbers. So ideally we want A and B to be whole positive numbers, whole and positive, so that A and B is in the simplest form possible. So let's come up with an example to what we're talking about. So let's say, for example, there are 6 girls and 4 boys. Okay? If there are 6 girls and 4 boys, then the way we write the ratio in the simplest way possible is not 6 to 4, but the ideal way to write the ratio is 3 to 2 for girls to boys. Okay? Even though there are 6 girls and 4 boys, we write this in simplest form as 3 to 2. Or we can write this as in a ratio or a fraction as 3 divided by 2. But this is the simplest form that we would like. All right? Now, a proportion is basically two ratios whose values are equal to each other. So a proportion is an equation, i.e. you have an equal symbol in between two ratios. So even though we said that 6 girls to 4 boys can be simplified as 3 girls to 2 boys, we can state the ratio to be 6 over 4 is equal to 3 over 2. Okay, both of these are ratios. Both of these represent the same ratio value. One is the simplified version and one isn't. Okay, now when we talk about a proportion, proportion only works if and only if it's equal. If two ratios are not equal, then they are not a proportion. So we can't say 6 over 4 is equal to 3 over 5. That's not true. That's an untrue relationship, so we have to cancel that out. They have to be equal to one another. So here is the new vocabulary. There's something called means, and there's something called extremes. The means are in a proportion. The means are the denominator of the first ratio and the numerator of the second ratio. So the means are the denominator of the first ratio and the numerator of the second ratio in the proportion. And the extremes is the numerator, or two numbers. One number is the numerator of the first ratio and the denominator of the second ratio. So those are called the extremes. So the extremes change based off of how you set up the ratio. We're going to talk about that a little bit later. So something that's new is something called the cross products property. And in a proportion, the product of the mean of the extremes is equal to the product of the means. So for example, here we have a lovely proportion, as you can see. And in the proportion, can you identify, oops, I didn't want to use that. Can you identify what the means are and what the extremes are? Well, the means if you said that the means are B and C, you're correct. And if you said that the extremes are A and D, then you'd be correct. So what the cross product property says is if I take the product of the extremes, it's going to equal the product of the means. So to fill this in, and you can fill this in your notes, since the product of the extremes, so the extremes are B and C, I'm sorry, the extremes are A and D, so A times D is going to be equal to the product of the means, which is B times C. So let's take a look at this example right here, in this ratio right here. Here we have a proportion, and what are the means? The means in this example are 3 and 4, and the extremes in this example are 2 and 6. So the cross product property says if I take the product of the extremes, they're going to equal the product of the means. Well, let's see if that's true. The product of the extremes would be 3 and 4. Is that going to equal the same as the product of the means, which are, I'm sorry, the product of the extremes, which are 3 and, sorry, I keep messing it up. Okay, I'm looking at the wrong thing. The product of the means is 3 and 4. So that's what these numbers are, the means. Is that equal to the product of the extremes, which is 2 and 6? Well, let's see. 3 times 4 is 12. 2 times 6 is 12. Yes, that will always work, because in a proportion, if they're equal, then the product of the means is equal to the product of the extremes. Okay? So how can we use that to solve proportions? Well, one way is we can easily identify if something really is a proportion. If someone says is 2 over 5 equal to 9 over 6, well, I can try and figure out the decimal value of 2 over 5 and 9 over 6 and compare, or I can just multiply the means times the extremes. So let's take a look. The means in this case are 5 and 9, and the extremes in this case are 2 and 6. So when I multiply the product of the means, I get 45. But when I multiply the extremes, I get 12. So that tells me that this is not a proportion, because the product of the means is not equal to the product of the extremes. So that's a little bit quicker way to determine if something is a proportion. And you've actually been using means and extremes and didn't realize it. So say, for example, I wanted to figure out, and I'm going to change to a pen so it'll look a little bit easier for us to write. Let's say I have 5 over x is equal to 3 over 9. Well, how do I figure out what x is? Well, most of you said from your middle school teachers that you would do the butterfly, cross, multiply, and divide. But that really is where the product, that's based off the product of the means of the extremes. Because remember, the means in this case are x and 3. So that means I can write over here, if this is true, 3x, 3 times x, is equal to the product of the extremes, which are 5 and 9. And 3 times x is 3x, and 5 times 9 is 45. Well, to figure out what x is, we have to do one more algebraic thing, which is divide both sides by 3. And we get our answer as 15. So in other words, I can replace this value of x with 15, and this proportion will be equal. 15 times 3 is 45, and 5 times 9 is 45. So when you were using the butterfly method, you were really using the cross product property all along. The last thing I want to talk about is this very new thing called the geometric mean. Now we know the arithmetic mean to be the sum of the average of two numbers, but the geometric mean is not the average. You're not going to add two numbers and divide by 2, but it's based off this proportion, and the proportion, as you can see, is that a over x is equal to x over b. So the geometric mean is the number x that makes this a true statement. So because it's a proportion, then that means the means are x and x, and it means the extremes are a and b. So by the cross product property, we know that the product of the means, x times x, is equal to the product of the extremes, a times b. So in other words, this is saying that x squared, here's my squared thing, I'll do squared, sorry, is equal to a times b. Well, if that's the case, then define what x is. How do I undo a square? Some of you are already saying it. You undo a square by taking the square root. So x is equal to the square root of a times b. Okay, so all that means right here is I can rewrite x as the square root of a times b. So x is equal to the square root of a times b. The geometric mean of two numbers is equal to the square root of the product of those two numbers. The geometric mean is equal to, x is equal to the square root of the product of those two numbers. Okay, so let's take a look at how this applies. Let's say I pick any two numbers, and I'm going to say, let's say I just pick 3 and 5. So I pick 3, oops, and I pick, okay, I'll do 3 and 15. So let's take a look. What is the geometric mean of, mean of 3 and 5? 15. The geometric mean of 3 and 15 is, we can set up the proportion. 3 over x is equal to x over 15. Or we can say x squared is equal to 15 times 3, which is 45. Or we can say that x is equal to the square root of 45. And that number is between, which is between 6 and 7. Okay, so the geometric mean is exactly the square root of 45. Oh, and that's the bell, so my advocacy comes. So talk to you later. Bye-bye.